Yes. Varun, listen.
Yes.
Find area. Find the area of one of the. Find the area of one of the curvilinear triangles. Curvilinear triangles. Curvilinear triangles bounded by, let's see, bounded by y equal to sin x and y equal to cos x. Bounded by y equal to sin x and y equal to cos x. Let me explain. Find the area of one of the curvilinear triangles bounded by y equal to sin x and y equal to cos x. What do you mean by curvilinear triangle? Nothing is there. You see here. Suppose this is a triangle, curvilinear triangle. This is a curvilinear triangle. Hold on. Okay, this is a curvilinear triangle. This is the triangle sides it long. That's it. It's in the form of curve. This is called curvilinear triangle. Okay, so let me explain how it forms in the case of both sin x and cos x. So we already know the graph of sin x and graph of cos x. Let me explain. I don't want to draw completely. Yes, I want to draw sin x first of all. This is sin x. You already know it touches x-axis at 0 and pi. You already know. And also, if you see, this is called sin x curve. And if you draw the cos x curve, what happens? This is minus pi by 2, it becomes 0. And at pi by 2, it will be 1. This is pi. Let me explain. This is pi. If you draw line. This is pi. Yes. I want the area enclosed by curvilinear of this one. So this one I want. Yes, let me explain. This is pi. And this is cos x curve. And this is sin x curve. Yeah. And you already know sin x and cos x are equal at pi by 4. Am I right? At 45 degrees, sin x value and cos x value are equal. It shows it is a point of intersection. Point of intersection occurs at pi by 4. Am I right? Yes, be clear.
Yes, sir.
So I draw only up to 0 to minus pi by 2 to pi by 2, I draw the cos x curve, and 0 to pi, I got the cos x curve. There is a point of intersection at 45 degrees because sin 45 1 by root 2 and cos 45 1 by 2. I want the area curvilinear triangle. So we got the curvilinear triangle. One triangle I can take. So if you see if you proceed by taking pi to 2 pi, 3 pi to 4 pi, if you proceed drawing the graph extending the sin x and cos x curve, you'll get so many curvilinear triangles. But their enclosed area is always same. You take one curvilinear triangle, whatever you get the area, even in propagation of those two curves, wherever you get the curvilinear triangle, there also their bounded area is equal because they are symmetric. Yes, now here. Now I want this area. So I want this area. Curvilinear triangle enclosed by these two curves. This is a sin x curve and this is a cos x curve. So area enclosed is this one. This is an area I want. This is an area. Okay, so let us see how you can calculate this area. Be careful, but just you know. This is a 0 to pi by 4. If you take this one, 0 to pi by 4, if you take. Okay, this is an area. What is this curve? This curve is a sin x curve. I'm right. This curve is a sin x curve because
sin
it's
x curve.
So 0 to pi by 4, the area enclosed by sin x curve. If you see from pi by 4 to pi by 4 to pi by 2, yes, you take pi by 4 to pi by 2 if you take, this is an area enclosed by this cos x square. Am I right? So
Yes, sir.
is here. No this area, not this area. Yes, only up to here. That's so 0 to pi by 4. This is an area enclosed by the sin x square, and pi by 4 to pi by 2, the area enclosed by cos x square. Remember, this curve belongs to sin x, and this curve belongs to cos x. 2 points you need to identify here. Very important. So 0 to pi by 4, the area is enclosed by the sin x square. From pi by 4 to pi by 2, the area enclosed by the cos x square. So let me explain how to calculate this area. Yes, let me explain about the area enclosed here. So if you see area here, so integration 0 to pi by 4, the area covered by the sin x dx plus, not minus, plus the area covered from pi by 4 to pi by 2, this area is covered by the cos x square. That is what it is. It's very, very important. Yes, here. You're traveling on this curve, 0 to 45. So this curve belongs to cos x, sin x. And pi by 4 to pi by 2, this curve belongs to sin x. So from in this curvilinear triangle, if you see 0 to pi by 2, if you take this area, what I draw with a horizontal line, that is a curvilinear triangle. Yes. 0 to 45, the area enclosed by sin. From pi by 4 to pi by 2, the area enclosed by cos x square. Okay, so this is what you get. Now, on simplifying, what you get is, now you already know the integration of sin x is minus cos x. So limits are 0 and 45 degrees plus cos x integration sin x. Its limits are pi by 2 and pi by 4. You're having like no here. If you take minus outside, cos 45 degrees 1 by root, yes, minus cos 0, that is minus 1, you're having, plus if you take sin 90, 1 by root 2, you get minus 1 by root 2 plus 1, plus 1 minus 1 by root 2, you get how much you get? 1 plus 1, 2, 2 minus 1 by root 2 minus 1 by root 2, that is 2 minus root 2, you'll get this one. So area is 2 minus root 2. This is 2 minus root 2 is a curve area enclosed by the curvilinear triangle bounded by the sin x and cos x. This is what you're getting here. Okay? Yes, you know. Find the area of one of the curvilinear triangle bounded by y equal to sin x and y equal to cos x. If you propagate the sin x, if you draw the sin x and cos x curve, so many curvilinear triangles we get, but their enclosed area is always 2 minus root 2 square units. 2 minus root 2 square units. So remember, it's very important. Sometimes the smart questions they ask like this. Yes. Find the area of one of the curvilinear triangle bounded by y equal to sin x and y equal to cos x. So many curvilinear triangles are formed. If you draw the graph sin x and cos x, if you extend the graph, you get. But the bounded area of the curvilinear triangle is always equal to 2 minus root 2 square. Nothing is very simple.